Lesson 7, Add and Subtract RVEs. For the warm-up, we're going to determine the lowest common denominator. And the reason why we're going to look at that is because we will be looking at adding and subtracting. Whether we look at fractions or whether we look at RVEs, we do need to look at finding the lowest common denominator first. So for the first example, we have a denominator of 3 and a denominator of 4. And we know that the lowest common denominator in this case would be any number that is divisible by 3 and 4. And ideally, we want the smallest number that's divisible by 3 and 4. And so in this case, the lowest common denominator would be equal to 12. For part B, you'll notice that the lowest common denominator in this case is not going to be just a number term. It's also going to have a variable part to it as well. So in the lowest common denominator, we want to see if there's anything that's already common between the two denominators and if there's anything missing. So any factors that may be missing versus any factors that are already common. And so what you'll notice here is that we have just an x, and here we have 2 multiplied with the x. And so you'll notice that already what we have in common is an x, and the only factor that's missing from the first denominator is a factor of 2. So the lowest common denominator in this case would be 2x. And so what that would mean is, in order to get these two denominators the same, I would need to multiply this fraction by 2. Okay? And so that would eventually give me 2x, and that'll give me 2x as well. And so then the denominators would have been the same. Okay, let's look at the next one. We're trying to find the lowest common denominator here as well. So again, when you're looking at lowest common denominator, you want to see whether or not there are any factors that are already common, and then what factors may be missing. And in this case, you'll notice that both the denominators have a factor of 4, so that's already common. That'll be included. And the only part of the denominator that's missing is x plus 3. The first denominator has it, but the second denominator needs to have that included as well. So what that means is I'm missing a factor of x plus 3 in the second set of brackets. Okay, now you can see that the denominators are common, and so the lowest common denominator in this case is 4 times x plus 3. One of the things I want you to notice is that because it's in factored form, it makes it really easy to determine which factors may be missing. Okay, so that's one thing to keep in mind as we look at some adding and subtracting of RVEs later in the lesson. Okay, in terms of the last one, again, we're looking for a lowest common denominator. And what you'll notice in this case is that these two denominators have nothing in common. Okay, so what that means is each of these denominators are missing the factors that appear in the other denominator. So the first denominator is missing a factor of 4 that exists in the second denominator. And the second denominator is missing a factor of x and x plus 3, which we do have in the first denominator. So the lowest common denominator would include all of these factors together. Since none of them are common, all of them need to be included in the lowest common denominator. So a factor of 4, a factor of x, and a factor of x plus 3 is what we need to make this the lowest common denominator. Okay? And so we looked at some examples where you have some factors that are common. And then we looked at examples where no factors are common as well. Okay? And so what this would mean is if I wanted the denominators of both of these to be the same, I would need to multiply the first fraction by 4 and multiply the second fraction by x and x plus 3 in both the numerator and denominator. And now you'll notice that both denominators are 4x multiplied with x plus 3. Okay? So that is the lowest common denominator. So when you are adding and subtracting RVEs, note that RVEs are added and subtracted in the same way that rational numbers or fractions are added and subtracted. The first thing you need is a common denominator before you can combine them. So steps for adding and subtracting RVEs. The first thing you need to do is factor both the numerator and denominator and then state all restrictions. These two steps have been the same no matter how we are looking at the RVE, whether you are multiplying and dividing them, just simplifying them, or adding and subtracting them. First thing you want to do is factor the numerator and denominator, and then the next thing you want to do is state any restrictions. Now, because you are adding and subtracting, the next few steps are going to be a little bit different. They're going to be related to adding and subtracting RVEs. And so what we need to do is determine the lowest common denominator. And using the lowest common denominator, multiply each expression by the missing factors. Much like what we did here in the warm-up. We first determined the lowest common denominators, and then I showed you how you would multiply any fraction that's missing any factor. For the lowest common denominator, you need to multiply it. And then, now that the denominators will be the same, you're going to add or subtract the numerators and keep the denominator part the same, much like you would when you are adding and subtracting fractions. So here's our first example. It asks us to simplify the following RVEs and state all restrictions. So what you'll notice in this example is that the numerator and denominator are already in factored form. This denominator here cannot be factored any further. So what I could do is state the restriction on the value of x. Now I know usually when we're solving for x, we would be looking at a difference of squares if there's two terms, but this isn't a difference of squares. However, you can solve for x. So I'm trying to figure out when x squared minus 2 is equal to 0, and essentially I don't want that to ever happen. And so if I'm isolating x, I'm just going to rearrange the equation to solve for x. And so to get rid of the exponent of 2, I'm going to find the square root of both sides. And whenever you do find the square root, it's plus or minus. And so you have x cannot equal positive or negative square root of 2. And so my restriction in this case is x cannot equal plus or minus root 2. Now, you'll notice that the operation is subtraction. I already have the two denominators exactly the same. So what I could do is write both of them under the same denominator. So since the denominators are the same, I can combine the numerator part. And so I have 2x plus 3 minus x minus 4. And the reason why I'm putting brackets around the x minus 4 is because you are subtracting, so all the signs inside the brackets are going to become opposite. And so essentially I get 2x plus 3 minus x plus 4 in the numerator. And my restrictions are still the same. X cannot equal plus or minus root 2. Now at this point, it's just a matter of simplifying the numerator by collecting like terms. So 2x minus x is x, and 3 plus 4 is positive 7. And you'll notice that the restrictions are still the same. Okay, so there's an example of adding and subtracting RVEs. Let's look at the next one. You'll notice in this one again, we're going to simplify the RVE and then state any restrictions. In this case, notice that the denominators have no variable parts to them. So in this case, what this means is we actually don't have any restrictions. There are no values of the variable that can make the denominator 0, which means we have no restrictions. So all we need to worry about in this case is what our lowest common denominator is going to be, because we don't actually have all the denominators the same in this case. So the lowest common denominator between 4, 3, and 2 would be any number that goes that can be divided by 4, 3, and 2 easily. And so in this case, the lowest common denominator is 12. So what that means is I need to multiply the numerator and denominator by the first RVE by 3 to make a denominator of 12, by 4 to make a denominator of 12, and then by 6 to make a denominator of 12. So the first RVE needs to be multiplied by 3. The second RVE needs to be multiplied by 4. And the last RVE needs to be multiplied by 6. And so what this would look like, since 3 times 4 is 12, 4 times 3 is 12, and 6 times 2 is 12, I can already write everything over one fraction. And so what I have here is 3 times 10, which is 30, minus 9b. And then I have negative 4 times 2b, which would give me negative 8b. And negative 4 times 5, which would give me negative 20. And positive 6 times 5, which is positive 30b. And positive 6 times negative 8, which is negative 48. And then finally, I can just collect like terms. And I have negative 9b minus 8b, which is negative 17, plus 30, which is 13b. And then 30 minus 20 is 10. Minus 48 is negative 38. And again, like I said, no restrictions in this case because we are looking at just numerical parts in the denominator and you don't have any variables in the denominator in this case. Okay, in example 2, we're going to find the lowest common denominator for the following RVEs. So the goal is just to find the lowest common denominator, not to simplify or anything in this case. And so what we need to look at is what the denominator is in each of these terms. So the first term, my denominator is this imaginary 1. In the second term, I have a denominator of x times y. And in the last one, I have a denominator of y squared. So our lowest common denominator has to have numerical parts that are exactly the same in each of the denominators and then variable parts that are exactly the same in each of the denominators. So starting with the number part, I have an imaginary 1 here, an imaginary 1 here, and an imaginary 1 there. And so that means that in terms of the numerical part, 1 is the lowest common denominator. In terms of the variable parts, because I have an x in the denominator of one of the RVEs, that means I need to have an x in the denominator of each of the RVEs. And so I know that x is going to be one of my variable parts for the lowest common denominator. Now, the second variable that I have here is a y. However, the last term here has a y to the exponent 2. So basically, this means I have y multiplied by y. And so because I have two y's in this case being multiplied and only one here, that means all my terms actually have to have two y's multiplying themselves. Or in other words, I need to have y squared as part of my lowest common denominator. So what that means is the first term needs to be multiplied by xy squared to get a common denominator. The second term would need to be multiplied by y to get xy squared. And then the last term would need to be multiplied by just x to get xy squared. Okay, and you'll notice that each of the denominators are exactly the same. Okay, for the next one, notice that in this case the first denominator is not necessarily in the most factored form that it can be in. And so before you try to determine the lowest common denominator, you do need to have it in factored form because you want to know which factors are missing in any one of the denominators. So we need to first write this in factored form. So the first denominator can be rewritten in factored form as x minus 2 multiplied by x plus 2. And then the second denominator is already in factored form, and all I'm going to do is put brackets around it. And what you'll notice in this case is that the two denominators that we have already have something in common. They both have x plus 2 in common. So what that means is x plus 2 is going to be part of our lowest common denominator. You'll also notice that the second denominator actually has a factor that's missing that we already have in the first denominator. And so this is the x minus 2 part. So what that means is the lowest common denominator is going to be x plus 2 multiplied with x minus 2. The factor that's common multiplied with the factor that's missing in one of the denominators.